He is an independent think tank professional who served Pakistan Atomic Energy Commission for 40 years as a consultant, advisor, Director General of Planning and Projects, Director Biosciences and Executive Secretary, Abdul Salam International Natia Gali Summer College. He is working with different think tanks as an expert on nuclear knowledge management and weapons of mass destruction, nuclear energy, and climate change. He is a visiting professor at 3 universities. He is a member of the editorial board of Insight International Strategic Studies Institute, Journal of Strategic Vision of SVI, and associate editor of Journal of Pioneering Medicine USA and Journal of Bioterrorism and Biodefense USA, advisor to Al-Muqit Labs Lahore and regional rep at Islamabad, motivational speaker to Siren ICCBS Comstech. So please welcome Professor Dr. Syed Javaid Khurshid.
Bismillahirrahmanirrahim. When I was coming here, and 2 days ago, Zafar invited me that you might say something in the conference. So the word of smart material really attracted me. And I thought I may speak as a think tank on the smart materials. What are they and what is happening? So instead of speaking on some materials, I give guidelines to the researcher here that the world is open for them and the doors are opening for the material research. I use a very different word. The doors are opening for the material research and basically the smart materials which we are talking, because the whole world is after new technologies, whether it is used in industry or civil or military purposes. Basically, there is a lot of emphasis on using the smart materials for the military purposes. Therefore, I want to give you the thinking that how vast the field is and why we are not working on the smart materials. We should work on the smart materials because the new technologies I have given a word here, new emerging technologies, because all the new emerging technologies which I will show you are going to use the smart materials. Okay, I will start with the thinking. It is decided that mankind has to survive in this world. Okay? When it has to survive, need to achieve, UN has given 17 sustainable development goals to you, SDGs. First there was MDGs, and we were unable to react on our MDGs. We were unable to achieve MDGs. Now they have given us 17 sustainable development goals. So if we achieve these 17 sustainable goals, because these goals almost cover everything, the key to all these goals is development. What we go after? We go after the development. Whether we are a scientist, whether we are an economist, whether we are a government official or anything. So we are going for development. And development is needed for the basic poverty elevation. And poverty elevation and all these things are covered by the 17 sustainable goals. For that, what we have to do? We need to control these 17 development goals, or to control the development, we actually need emerging technologies. The word emerging technologies is not a simple word, because there are different categories for the emerging technologies. Nearly, the world has pointed out 80 emerging technologies. Out of 18, they have reduced very essential emerging technologies to 30. Okay, from that they have also reduced it to 9 or 10 technologies which are really needed for the development world and now for the military purposes and for everything. they need 9 or 10 technologies. And these 9 or 10 technologies depend on new and advanced materials. So you can imagine why the smart materials and new materials or advanced materials, whatever you use the word, is essential for us to work on and to get research done and to get them in production. What I mean, I don't just stop at research. Research is okay. Publications, to get the publications is fine. But unless you bring it into application, you cannot achieve a development. You cannot bring your country up. So just publishing a material is very important, but not very important when I talk about the development. I talk about bringing the country up in the advanced countries. Why we are not counted in advanced countries? This is the main thing what I'm talking about. Unless we bring it to the practical application, we won't be called as advanced country. Most important area, let's see, what are the most important areas in the coming new emerging technologies and their impact on the safety. When I will talk about new technologies, when I will talk about new materials, when I will talk about new emerging technologies, it is very important to get an idea that beside that, safety and security is one of the important things. Because, see, getting control on the new technologies, getting control of new materials, you have to keep safety and security in your mind. And the procedures first. Okay, what are the emerging technologies? They are technologies whose full potential is still unrealized. We have to see that. Breakthrough on emerging technologies such as artificial intelligence, cyber security, 3D laser printings, drones, biometrics, nanotechnology has already been made, and some more may have been on the way. These technologies are essential for contemporary advances and innovations in various fields of science and technology. The potential benefit of emerging technologies are enormous. Let's see. Artificial intelligence, autonomous systems, robotics, biotechnologies, communication, and networking technologies. These are the things after which advanced countries are going. Human-machine interface. Oh, this is very important. And microelectronics, semiconductors, and microelectronics, space technologies and systems. These technologies relate to including cyber warfare. See how the things are changing, how we are getting near to the very dangerous materials, including cyber warfare. Current weapon systems and existing modernization are human sensors. Okay. Now, in 2022, some more technologies are included in the new technologies. They are hypersonics, directed energy systems, renewable energy storage systems, and nuclear energy. These are recently included in the new technologies. Okay. New materials. Now, we see how the new materials are helping these new technologies. First, I talked about the new technologies. First, I talked about the development, how the development depends on the new technologies. Now I am talking about how the new technologies depend on the new materials, on the smart materials, and how we can support these new technologies. A country must continue to develop new technologies to stay ahead of its adversaries. Means, if we are living in Asia, we have to see what changes in new materials and taking place in India, in China, and people around us. Critical and emerging technologies, we have to discuss that. Advanced computing, advanced engineering material, I pointed out that. Advanced turbine engines technologies, advanced manufacturing, advanced network sensing. Now, the new emerging technologies need innovative materials. So, when we come to innovative materials, what is lacking? Why we are not doing that? Technology today is evolving at a rapid pace, enabling faster change and progress, causing an acceleration of the rate of change. The pace of new material development has increased about 20 times. See, our pace is very slow. Somebody really asked me that how you place Pakistan. See, we are at a very slow pace. And even adopting that pace, we are not able to give this material for the industrial uses. See, if we give this material for the industrial uses, then actually we are progressing. If we are unable to do that, if we are unable to bring the industry towards that, we are not progressing. So, to be a progressing and developing countries, we have to do research like that it should be adopted by the industry. New materials are the key to addressing challenges in energy, health, care, and national security. Healthcare, a little bit pointed out by the NM Butt about the nanotechnology, how it is used in the healthcare processes. Now, my emphasis will be like to this, because I'm talking broadly, I will say challenges we are facing in energy productions, challenging we are facing in the national security. They depend on the new materials. So are we developing those new materials? We should ask, as a scientist, we should ask this question to ourselves. Are we developing those materials which can be used by the country? Are we developing those materials which can bring us to a developed country? You should ask those questions. The computational, okay. First I pointed out, now it is very fast. Second, I will say the computational predictions are giving acceleration to the material discovery. Have we developed this computational prediction system somewhere in the country which can help the scientist? Material discovery and broader material research community should think about it. The best condition for industry and scientists will be there, should be there, not will be there. Okay, let me give you an example. Using conventional approach, it used to take an average of 15 years, 10 to 15 I will say on the safe side, to conceptualize and commercialize a new material. See, I said commercialize, 10 to 15 years. Conceptualize, you can say 5-6 years, but have you done the commercialization of these materials? Because I'm gauging the research to bring the fruits to the general population. Therefore, I use this word. Now, the supercomputers approach. Now we have supercomputers, and the developing countries are using supercomputers for the material research. To material science has made it easy by removing the guesswork for material design. So now we don't have to guess the work. We should go to the computerization and chalk out what should be the what should you do and what should be the design and what should be the things of the material you are working. Now, computer experimentation and characterization enable to develop of a better predictive material models. Advances in material discovery. Now it is easy to evaluate existing experimental data to discover new compounds. The data can help in two ways. Data can be used to refine methods. It will improve models. It will build confidence in predictive models for the users. The database of more than 31,000. There are different database banks, but one which is used in US is nearly 31,000 materials are present on it. And about 5,000 users are using them. And you can see about 20% from industry and 20% from government, and remaining by the researcher. So researchers are using 60% of this data available. Now, I will ask the question afterwards, but I'm just giving an example here. I will mention the recently discovered materials just to see when I was looking that a material is really recently discovered in the material sciences, and that material is an alloy of chromium, cobalt, and nickel. And it can go to minus 424 Fahrenheit degree centigrade, and is highly malleable, impressively strong. Ductility improves with the temperature going down, and material scientists understand that what I mean. New materials are affecting all aspects of life through innovations that enable, for example, what physical properties and what chemical properties and what transportation properties they have is the things which are bringing this research of new materials up. Strong, lightweight for aerospace applications, clean, accessible for drinking water around the world, superfit computers with vast amount of storage, self-cleaning surfaces, wearable sensors and health monitors, safer foods through packing and monitoring, regrowth of skin, bones, nerve cells for better medical outcomes, smart windows that lighten or darken to convert energy, and nanotechnology enabled concentrate that dries more quickly and has sensors to detect stress or corrosion in roads, bridges, and buildings. Sensors enabling handheld gas sensors, portable bioassays, photonic sensing, electromagnetic field, ultra-fast lasers, enabling tabletop X-ray sources to provide nanomaterials, resolution, 3D tomography, low-cost photocells, material for fast charging and high energy density, use of carbon nanotubes, yarns in stitched hybrid composite for enabled damages tolerance, nanoparticles for targeted and controlled delivery of images, and advanced for HIV vaccines. They can be used. There are other sides of this materials. I am giving just one example. So they can be used in warfare things. So now we are discussing a lot of nanomaterials in the chemical weapon control systems, chemical weapon conventions, biological weapon conventions, and other uses to make laws for these nanomaterials and nanoparticles and materials of dangerous nature, because they are of dual nature. Dual nature, they can be used for the betterment and they can be used for the dangerous purposes. So there is another side of these nanomaterials you have to understand when you do the research. Materials are far more reactive, unpredictable than normal chemical and biological particles. Nanotechnology has accelerated existing threats and created more novel and more complex threats. A more proactive policy framework is needed for different materials. Here you see, I have used a proactive approach. Why I have used that word proactive approach? When you see in Pakistan, it is not a proactive approach. We have an approach when we get affected by something. So it is a reactive approach, not a proactive approach. And there we are getting negative results in climate change. Because all the approach in the climate change is reactive approach, not the proactive approach. Because we have laws from 2012 in the climate change, but they are not implemented. We use them when we get some disaster. we have a disaster management cell, but it is activated after the things. So it is a reactive approach. There is a need of assessment. Now, when I say that materials can be dangerous, there is a need of assessment of material development and elements to CWC, BWC, Webinar arrangements and UN Resolution 1540. Instead of individual, state parties should be assessment. A formed collective assessment should be made by collective bodies, participated by state parties, policymakers, scientists, industries, and civil society together to exchange ideas and to understand different aspects of the problems. Next, proposal under the consideration to ensure greater security are under formulation and will be presented to the state parties. Biosecurity and strengthening the BWC should be Biological Weapon Control Convention, in which the nanoparticles and all these particles can be controlled by this method. Assessment of their relevance to the expert. Material research will go beyond and will include cyber, robotics, artificial intelligence, 3D laser printing, extra. These are the new technologies which are making change. And the world will be different in 2030 by these new materials and new technologies. The solution is not to ban these products or stop material research, but rather to systematically study the safety and security of the materials and to ensure a communication flow between all stakeholders, mean industry, researchers, and policymakers. Okay, I will go straight to the last one. It is suggested international law is required to govern the safety and security of a material. The major hurdle is the disagreement on what exactly is to be regulated. Last point, the takeaway. Whatever I said, what is the takeaway of that? First, to remain in competition with the material research in the world. First. Second, it is a need to work on new materials for advancement and to adopt new emerging technologies where we should use. Third, researchers need top-class computer facilities for computation, predictions, and acceleration in material research. HEC should look into it if they want the material research to be done. And the last one, researchers should have free access to advanced material data banks of the world.
ये रिसेंटली जो एक आ गया है, मैं इसको कहती हूँ सिवाय स्केल के और कोई बात नहीं, नैनो मटेरियल जो क्रिस्टल स्ट्रक्चर होगा आंगस्ट्रॉम में, तो वो तो 10 टाइम्स छोटा है कंपेयर टू नैनो साइज. ठीक है जी. तो मुझे तो लग रहा है कि ये नैनो इज जस्ट अ स्लोगन, नथिंग एल्स. आप जब मटेरियल्स की प्रॉपर्टीज प्रैक्टिकली मेजर कर रहे होते हैं तो वही मटेरियल है आप बल्क फॉर्म में उठा रहे हैं. वही मटेरियल है मैं XRD को दे रही हूँ तो कम से कम आधा ग्राम तो होता ही है, तो वो बल्क फॉर्म में ही होता है. और जो नैनो मटेरियल हम कह रहे हैं वो एक स्केलिंग ही है. तो इसलिए ये जो मेरा ख्याल है कि वो स्केल इसलिए आ रहा है क्योंकि हम कहते हैं जी माइक्रो, ठीक हो गया, उससे पहले हम मिली की बात करते हैं, फिर मल्टीप्लाई बाय 10⁻³ और किया तो -9 मीटर हो गया. ठीक है. लेकिन ये जो हमारी बातें अक्सर होती हैं कि जी नैनो स्केल पे जाके मटेरियल की प्रॉपर्टीज़ चेंज हो गई, मुझे तो उसमें कोई ऐसी चीज़ नज़र नहीं आई, क्योंकि मटेरियल जब मैं उसको लैटिस कांस्टेंट को ही उठा रही हूँ तो जो प्रॉपर्टीज चेंज होनी है वो तो उसके लैटिस कांस्टेंट पे डिपेंड कर रही है. सो दिस इज़ अ क्वेश्चन विच कैन नॉट बी आंसर्ड सो क्विकली, बट गैलेक्सी ऑफ साइंटिस्ट आर सिटिंग, सो दे शुड टेक होम एंड वी शुड थिंक अबाउट इट. व्हाई वी आर सेइंग सो मच बिग स्लोगन नैनो मटीरियल्स, though the lattice constant is 10 times smaller than that scale. Thank you, sir.
इसका जो निटी ग्रिटी जवाब है वो तो मैं भट्ट साहब की तरफ रेफर कर दूंगा, लेकिन आपके सवाल का जनरल जवाब मैं देता हूँ। वो ये है कि I didn't absolutely talked about nanomaterials. I talked about, just a second, let me finish. I talked about the new materials, I talked about the smart materials, I talked about the materials. So this is one of the property. Property can be different, millimeters, nanometers, anything. We are not concerned with the properties now. As a scientist, you have mentioned that. But basically, my lecture is to see the uses of those materials. What are the uses? Where they are used? I am not concerned about a 10 millimeter or millimeter or nanometer or something. Where they are used? Why they are used? Because they are used by their properties. And if they have the properties, they are used there. This is the second answer. Third, we should go on their uses. As a scientist, you can suggest that they go there with this site, they go there with this site, and with this site we can use it. We can use these properties to our advantage. We are not concerned that why we define them like that and why should we define. And this is explained by the Bhatta in his lecture that initially they were called as advanced materials, they were called as smart materials, and in 1975, by the Japanese, they are called as nanomaterials. So you can give the definition. I'm just concerned about application.